Hello, everybody. My name is Mauro. I am a software craft person at Codurance, and today I'm joined by my colleague, Cameron.
Hi, my name's Cameron. I'm also a software craftsperson at Codurance.
So great. Today we are going to show you a solution that we have for one particular kata, the Simple Mars Rover kata. So first, we're going to go through the exercise itself. Then we'll show you a solution that we have, which is functional, but we're not really happy with the state of the code. And then we'll show you how we refactor it to use design patterns. All right. So this is a definition of the problem. We are using a simplified version, the Simple Mars Rover, which you can find at codurance.com/catalyst/simple-mars-rover. I hope I pronounced that all right.
Yep, absolutely fine. Yep.
All right, cool. Do you want to tell the viewers what is this all about?
Yeah, absolutely. So for those who don't know, the Mars Rover kata, or in this case, the simplified version, it's a kata that we use quite a lot of Codurance for interviews and for general language practice and pattern practice, etc. What it's based on is you have a vehicle, which in this case we sort of imagine it as a Mars Rover, and you will send the command to move. Now, of course, moving depends on which way it's facing, which direction it's facing. So if it faces north, then moving forward will, of course, send it further north, east goes further east, etc. It has a position on the grid, which is represented by an XY coordinate pair. The compass, or some kind of navigation module, which looks after the direction it's facing. And traditionally, we start the kata at 0, 0, n, which is to say 0x, 0y value, and facing north. And that's the location and the direction, or rather the position and the direction it's facing is represented as a string of 0:0:n or x:y: direction. So those are the main points regarding the simplified Mars Rover kata.
Okay, cool. So the way this program works, it will get an input from the command line, which is just a simple string containing the commands that the rover is supposed to execute. So the commands can be L, stands for a rotation to the left, R to rotate to the right, and M will simply move the rover 1 square forward in the direction it is currently pointing at. And one very important detail is if the rover reaches the end of the plateau, of the end of the board, it wraps around, meaning it will step from position 10 back into position 0 and all around vertically and also horizontally.
Yeah.
And so finally, the output, or the goal of this program is to given a set of commands that the rover must run, and the program must return the final position and also the direction that the rover is facing. And so here's a very cute example of how the starting position and the commands are executed and how the rover is moving through the screen. All right, so I guess that's the basic definition of the problem, and we have here's some interface that we can use. Another thing about the rules, I think we're pretty much covered, right?
I think so. Yep.
All right, cool. So let's move on to our starting point, the basic implementation of the solution that we have, which we are using Typescript here. So here, what we have on the left-hand side is the tests for the implementation that we will be discussing shortly. So maybe, Cameron, do you want to comment on the tests?
Yeah, absolutely. So just as a quick explanation as to what all of this means, these are parameterized tests. So because we have many tests which are very similar in how they test the solution we have here. So on the left hand column, if you like, of we'd call that the expected result. So those would be the X coordinate, the Y coordinate, and then the direction the rover could be facing in. So this would be an overall representation of the position and direction of a rover. And on the right-hand side, that is the command or the string of commands that should bring the rover into that state. So on line 5, for example, we expect after a command of L for our rover to be at position 0, or X should be position 0, Y should be position 0, and W should be the direction after it's sent an L. That is, of course, making the assumption we mentioned previously that the rover always starts facing in a northerly direction. And so we have several examples afterwards, just to check how it should look after 3L commands, for example. And further down, you can see we have several examples of the R command being tested, the movement command, and then we get some more complex behavior at the bottom where we mix and match some commands, and we get the expected result there as well.
Right. So one detail that is very important, if you look at a test, for instance, like this, the number of M's is not really arbitrary or rather coincidence. We are forcing the rover to do the wrapping around. So we want to see how that behaves. Okay, so you can see how we have simple tests and some more complex ones as you move down the list of examples. But at the end, the test itself is always the same. We are simply asking the Mars rover to execute a series of commands, and we want the response to be what is expected. Okay, so before we jump into the code, let's verify that it's actually working. So let's run the tests. Okay, so as you can see, we are starting from implementation that is already valid. So why, since we already have a solution that is working, why are we doing this at all? You know, that you might be wondering, and now hopefully when we show you the code, you will get a better understanding of why we want to improve it. So here's the implementation that we have. It's a Mars rover class where we have the very main method called the execute, which takes the input, which is a command string. So it's a string which contains comments. And we are going to simply split this string by, well, we know that each command is made of one single character. Mm-hmm. So we can simply split it, and for each one of them, we will try to execute one of these commands. And finally, it will build the output given the position and the orientation that the rover has.
Yeah, absolutely. And further down, when we get to the execute command, I think this is really, the beginning of the refactoring, the first point in the code where the refactoring starts to come into, where it begins to be obvious that we could do with a refactoring here. So we come down here to move left, move right, and then we follow those methods. We'll see what happens when we do send in the L command, for example. We go to rotate left, and we'll see how that's currently handled, which is a switch statement here. Generally speaking, switch statements are sort of a sign, but something could be designed a little bit differently. And so that's what we currently have here. And what we'll also see after looking at this, if you look at the rotate right method as well, you'll see that it's actually essentially it's almost the same code, really. We've just got, obviously, if you're facing north, for example, and you turn left, you end up facing west. And whilst we're handling that, you can see that our rotate method is quite a lot of code for something that does something essentially the same, but just to the other rotating in a different way. So those will be the main focuses, I think, for the refactoring.
Yeah, if we take a look at the move forward, we can see that while the implementation is not really similar to those of the rotation, it's relying on a switch based on the orientation. So we have a few thoughts on this implementation. So the first thing to note is I want to reiterate this, that this implementation is correct in the sense that it fulfills the the acceptance criteria or the functional requirements. But since we're here and we are craft people, we want to go a little further beyond the bare minimum solution that will satisfy the requirements, and we try to put things in a way that allow for the implementation or the system to grow over time without it being a real like a headache. So I'm going to take it as a little interview here, but why do you think that the fact that this is relying on the switch statement is so bad?
Well, personally, I think we look at some of the principles that we try to follow when we're writing code. I think you could definitely make an argument for the second point in solid. The open for extension, closed for modification principle. It's not being followed as well as it could be here. So, for example, at the moment, this particular solution is only dealing with northwest, south, and east. But in the future, if someone decides we want it to be a bit more precise, we want to introduce diagonal directions as well. So northeast. You've got to modify the code in quite a few places at the moment to incorporate that new feature. Ideally, what we'd like to have is some kind of design where we can really make that separation between the logic that's handling the rotation or the movement away from where it's getting called, so that we can add new functionality without disrupting the existing code that we know to be working already. So I think that's one very valid point here. Another few points here. There's another few things like with object calisthenics, for example. The way that at the moment we've got I was going to say that we could talk about the different directions that are being represented by magic strings, but I suppose we probably won't get into that today because we're just doing the
I don't know. We can discuss that.
Yeah. Okay.
So yeah, sorry. One other thing, one other point I wanted to make is the fact that I particularly feel a little uncomfortable with the class being this big. Like it's probably expressing, and we can see it very very quickly, that this class is probably doing too much, and we can make a little list of the responsibilities that this class has. For instance, it has to handle the splitting of the command, which means the interpretation of the command for once. Then it has to execute the command, which at the same time, this means doing the rotation and also the movement. Okay, so that whole thing for me, it's a clear sign that the S in solid is not being followed here. So in summary, we have quite a bit of work to put this into a better shape. So let's see how could we go about that. Here is the project structure. Let's take a little look. We have the source, we have the test, and the Mars rovers, and that's it.
Yep.
So maybe we can do a little better, but at the same time, it's very important for us not to break the test while we do this. Okay.
Of course. Yeah.
So, what do you say? Where should we start?
Well, I like your idea of listing the responsibilities because, when you look at the structure of the project and you see that there is just a Mars Rover class, that furthers your points that it's very likely that this class is doing too many things. So I think we could look into our current Mars Rover class and see if there's something there that we can extract out into a separate module, perhaps. See if we can identify which responsibilities deserve their own class.
Cool. So I guess something you kind of mentioned when going through the code is the fact that this probably the orientation could be something better if we were to model it in a probably more let's call it an intelligent way rather than a simple string. What do you think?
That sounds great. Yep, I think we could represent that state as its own entity. Yep, that sounds good.
Yeah. So let's do this. Start with what do you say? Orientation sounds good.
Sounds perfect. Yep.
Right. So on the orientation, if we want to really take it to use some design pattern, for instance, what we could do is create a simple state machine here where each orientation can return or can know which are its immediate neighbors. Okay, so so in that sense, we might want to do okay. So let's try to do. Am I writing anything? No.
Yep, I can see that coming up.
So if we were to use an interface for the orientation, we could say something like, let's see, what's on your left, and this should return another orientation. So in a way, we are going to be implementing the orientations also as some sort of value objects. So let's see, you have your orientation left and your orientation right. And the interesting thing about going like this is if we were to add a new orientation, like for instance, something like northeast or something, we wouldn't really need to change anything about the other orientations, which would not be affected by it, or also the rotation or anything like that. If we implement it this way, when we call the method rotate left, it will simply have to take the current orientation and replace it with the orientation that comes from asking the current one for its left neighbor. Okay?
Absolutely. Yeah.
Cool. So let's try to do that. So basically, right now, we will need 4 classes which implement this interface. So let's see them. Like we should have our, let's start with the north. So let's see. North, which implements orientation. So if we say something like, let's see, we need to implement the methods. So we have our north class, which should implement the methods defining the interface. So let's see. Okay, cool. So if we are facing north and we want to turn left, then we will have to return a new object, which will be, if I'm not mistaken, it will be an east, right?
Nope, that would be west.
That would be west. Okay.
Yep. I always
get that wrong.
I've done this kata so many times that I still have to think about the compass in my mind when we do that.
Right. Okay, so since these classes don't yet exist, it will be in our best interest to create them right now. So
absolutely, yeah.
Where is it? Oh, I was expecting it to create it somewhere else. No. Okay, no problem. For the time being, I'm going to put them all in this one file, and then later we can take them somewhere else.
Yeah,
maybe. Let's see if we can we do it from here?
See if I can
copy file.
Move. Yeah. I'll see if I can move them if you like. Whilst you're building the different classes, I can place them in a. I can separate them into their own files.
It seems to be fine.
Okay.
Okay. Yeah, it did exactly what I was hoping. So cool. All right. So if we are facing west and we want to go left, then we should be facing south. Yes, and if we are on the other,
we should go back to north. Yeah.
North. Okay. And let's create the class south. Move it somewhere else. All right. So if we are left on the south, then now we are going east, right?
South, we turn left, then yes, then it should be
All right,
going east.
cool.
Yep.
And so now we are going west. Okay, cool. So we need to create the east class. Let's move it to east. All right. And so now when we are east and we move left, we go north. And when we go right, we go south. Okay, cool. So I think we have all of our orientations. So
Yep.
That's cool. All right. So now how would we go about the Mars Rover implementation? So it would be simply, we should say that the orientation will not be a string, but rather an orientation. So at the start, we will be facing north.
Yep.
And when we want to rotate left, we will simply say, we will go, I'm going to, okay, let's take it. This dot orientation will be this dot orientation dot left. Oh,
Yeah.
That's nice.
Yeah, much nicer.
That's
so what
really,
we've done,
really, really nice. And
much cleaner. So we've identified there. So a lot of the functionality is very dependent on what we were referring to the orientation throughout. Previously, we just had it as a string, but there's obviously not very much a string can do when compared to a class. We've identified that it has a certain amount of importance to the functionality of our Mars rover. So we've heightened, or we've brought up its importance, if you like, by moving it from a string to its own class, which gives it its own encapsulation with its own data and methods and things like that. And by refactoring into that, we've separated the responsibility for rotation into its own class, which is fantastic because that's helping us follow the single responsibility principle. And then, as we've mentioned throughout, if we do want to introduce another direction, like northeast, for example, then rather than having to change the code within rotate left or rotate right, which is what we would have had to do previously, we can simply add to our collection of classes, as you can see in the file structure here, just add one there, and we define what turn left means in that context, what turn right means in that context as well. And there you are, you've added that direction without having to disrupt the functional code that we've got. So that relatively small change has brought those two rather significant improvements there, like that. Mm-hmm. So yeah, I think it's a great direction for the state machine that we're building.
Mm-hmm. Yeah. So this that we did here is we are applying the state pattern. So at the end of the video, we are going to leave a link where you can go through the whole catalog of patterns. But this is the idea, where we are modeling the directions, the orientations of the rover as a state machine. So the next step is to fix this. So so now I guess we should probably do something very, very similar, saying what would be the next position of the rover, or maybe something we could do is to have the orientation provide a delta for each coordinate, for the y and the x. So that way we will be able to get rid of this switch as well. So let's start with the orientation. Let's give it a new one, which would be the next position. Let's call the next position. I don't like that name. Maybe okay. Let's say move forward.
Yeah, sounds good.
Something like that. And so from here, what we could probably do is to put together a new class to hold this. I would say, let's call it maybe movement. So the idea of this class would be to have the increment of each coordinate.
Okay.
No, oh, cool. Yeah.
Okay, that sounds great. Yep.
So let's take it away. Okay, so the movement class would have a simple constructor called, let's call it x inc, which would be a number, and y inc, which would be another number. And so, see. And so now, okay. Okay, so now we will probably need to project this out. So, right.
Oh.
Let me just.
Oh. I did try to use the IDE to do it automatically, but it didn't seem to like it. So I'm just going to do it myself, I think. Okay, it really doesn't like that.
It should be a Y right there.
Yeah, I keep adding Y and the IDE keeps doing something funny, but I think it's hopefully accepted it now. There we go. Okay.
Okay. So I'll say, give me the number. Can I do this, or is it? Oh, okay. So
there might be some clash there with the names. Yeah,
that doesn't
JavaScript under the hood.
Okay, cool. So let's. I want to start here by doing the client side of this class rather than the implementation for a minute. So let's assume that it's already there. So the idea would be that when you want to move forward, what you will do is do something like, let's say, the movement would be the orientation, the current orientation.
Yep.
Dot move forward. And then this dot x would be plus equal movement dot x. And this dot y plus equals movement dot y. And that would probably be it for the time being.
I think we might have some issues regarding the wrapping when we wrap around the grid. With that there.
All right, yeah, you're right. That's very true. But we can leave that for the test to
sure, yep.
to show us. But the idea would be this one. So I kind of like this one. So we have something in red. What's wrong? Create class orientation. Why? No, I don't need to create the class. I probably need to
just import orientation, I would presume, but yeah, doesn't seem to be an option on my client side. But
orientation from orientation. Okay, something seems to be wrong here. Orientation.
Is it exported?
Oh, right.
The classic JavaScript, TypeScript.
Export interface.
Yeah.
Okay, cool.
There we go.
Now, what is?
I imagine that probably means that we can automatically bring it in. Yep. So now the ID recognizes it as something we can import.
Okay. Right. So now
maybe West is the same.
Yeah, but the problem here is we are lacking the
Okay.
Movement. Okay. So I want to import. All right. So now we can see when we are moving north, we want to do nothing with the X and increase the Y by 1. Okay. And what is? Okay. Right. So let's see the other ones. Looks like we got some things to fix.
Yep.
Okay, in order to keep the video a little shorter, we just completed the orientations behind the scenes. So let's see how they are now. So you see, here's the move forward for the west, and we can see this same. We were looking for the south and north and everything. Okay, so now if we were to run the tests. Okay, so we can see that we have a little problem that we didn't have before, which is that the expectation here, let's see, difference. We were supposed to get a 0, 0 W, and we got a 0, 0 and object. So what is happening here is since we changed the internal representation of the orientation, which now is an object where it used to be a simple string, then we need to probably make some change to the way that we do the output. So let's see.
I think this fits quite well into our discussion earlier about the single responsibility principle not being followed here. We mentioned a lot of things this class was originally doing. One of those things is it's also responsible for taking this state that it has and creating this string that gets returned to the client when Mars Rover is used. So this is also a great opportunity to extract that responsibility elsewhere as well.
Yeah, I was thinking of doing exactly that. Yeah, we could do this, like we have this build output function, which is nice that we already have it somewhere like put away, but we can take this one step even further and bring this particular responsibility to some other collaborator. So let me try to do that. Maybe I can extract method. Okay, it didn't really work as I expected. Let's try again. Okay. Since should represent a set of statement or an expression. Oh, I see. It wasn't where I was looking for. Maybe move, build output. Okay, now it looks better. So I want to move it to let's call it maybe we could call it output builder.
Yep, that sounds good.
That's what it will do. Let's see what. No, it's not moving the method.
Let's go and do it the old-fashioned way.
Yeah, I'm going to try it one more time, and then if it doesn't work, okay, right. Let's do it the old-fashioned, right? So let's do this as I said, output builder.
Okay. I was just going to say for following the naming convention we have, maybe output underscore builder.
Oh, right.
Sorry.
No, that's fine. Okay. So now let's export a class called this one I'd like to go with this. Okay, so our output builder should simply first let's do this builder. Of course, here the method should be public. And okay, all right. So now, okay. So probably what we want to do is simply to take the parameters.
Yep.
Here. And then let's say the orientation, which would be some orientation. And okay.
Great. Okay, so now as we've introduced that orientation as a class, we've still got the original problem here regarding a string being returned. So we're still just returning an object. So I'm not sure how TypeScript handles this by default, but I presume that we probably need some kind of toString method or something like that, so we can get back the representation we originally were looking for.
So maybe here we can do a toString method on the orientation, and that should be that should work. So let's see.
It looks like in TypeScript's case, at least, you can just pass an object in, and if you haven't explicitly given it a method or something to produce a string, then TypeScript seems to default to using the built-in toString method, which is it's pretty clever. But in this case, the requirements we have for this kata are that we present the orientation in a particular way. Fortunately, TypeScript makes it quite easy for us to override this default behavior. So we'll just do that for each orientation class as well.
So let's see what should do. Why isn't it?
It might be, I imagine it's not complaining because technically toString has already been, it does exist, but it's just we want to override it. Yeah,
that's true. So let's see. So now I'm in the south. I wanted to return an S. In the west. To return W. And what else? North would be and east should be. Okay, cool. So now if everything goes right, let's see, run. Okay, cool. So now we fixed some of the problems that we had, like the first test. But as we can see, there is one test that is failing. It's a really interesting one because the problem is we haven't really modeled the wrapping around very correctly. So okay, so how do we do that? So on the movement,
I think this might tie in possibly with something that we mentioned earlier about the entities that we're choose to represent certain value objects in this kata. So the coordinates at the moment are just simple strings. I think if we did something similar to that we did for the orientations that have a coordinate class, we might be able to better isolate this functionality that can treat the output as according to this grid functionality, whereby we can validate, if you like, the output based on how large this grid is that the Mars rover is navigating.
Let's do that. So I like this idea of let's use a coordinate system. So let's see. Coordinate. So the coordinate class should have its x, which would be a number, y will be also a number. And so here we probably want to do these validations, like maybe if x, let's see, if x is more than over 9, then let's see, this dot x should be x minus 9, right? If it's 10, then it should be, well, minus 10, I think. Yeah. Okay. Let's see if, what about this? If x is lower than 0, then means that x should be, so if we are in -1, it should go to x, I guess, x plus 10, right?
Yes.
It looks something. Okay. And probably the exact same thing goes for the y.
So I would say so.
I'll do this for now, and then we can refactor to remove the duplication. Change this y, this y should be y plus 10. Yeah, I think it will work for this. Probably we want to do something more like a division rather than addition and subtraction, but okay, for the time being, I guess it will work. And what's the matter with you? Okay. Okay. And so let's see. We can do no, let's do this. X should be public, right?
Yep. That should be this .x as well.
No, yeah. Okay.
Great. Okay.
So now we have the coordinates, all right, and there's something still missing here.
Yeah, I think it's because technically there is a possibility that it goes through all of the if statements without without assigning the X. So I think maybe at the end we can have a default.
All right.
Yeah, we still need to have a default.
Let's see.
Well, actually, maybe that should go at the beginning, and then it will still run through the edge cases here, won't it? So
can I do it like this? Maybe. No, that's right.
It was still
No, those are the parameters, right?
Mm-hmm.
Right.
So there's still a chance that so basically if our input is valid, and by that I mean none of these cases apply, it's actually not getting assigned to the class at this point.
Okay. Yeah. Okay. What's wrong with the constructor? Okay. Yeah, I didn't use it yet, but so going back to the Mars Rover, so the idea would be to have a position. Let's see which would be coordinate. No, okay, I couldn't. Okay. All right, cool. So now that we have the position, then we probably, we can remove this this build output. We need an output builder for that. So let's put it here. Builder. For the time being, I can simply construct it here. Okay. And so I would say that this dot output builder dot build output. And so here we are going to have to change the signature of this build output for a little bit to use the coordinate. Let's see, this position and this orientation. Okay, that looks nice. Yeah.
Right. Okay. So we can.
And we have something. Okay, we will need to do something with this. We'll get to that in a little bit. But let's change this to position, which would be a coordinates. And this would be position dot x and position dot y. All right, I like it. Cool. And so now we can get rid of this. And then all right. So now what we should say is that move forward will be this position would be a new position, new coordinates. Coordinate, which would be this. Okay, position get X
Mhm.
plus X. And the exact same thing would be for the Y. Okay.
Great.
I'm not 100% on the naming, but I think it can work.
Okay.
What do you think?
Yes, we can always do a refactor later once we've got the functionality working again. We can take another review of how we've done it and make some improvements. So
okay, cool.
Good.
Let's run the tests and see what we got. Okay. So we got some good and some is not working. So
I think I know the problem in the constructor for the coordinates when. Like I say, we're not actually applying the values in the constructor unless it's an edge case at the moment. So
yeah, right.
I think we could start out.
Yeah, I totally missed that one.
So if I redo it like forgive me for using my weird. This IDE doesn't seem to be playing ball with me very much. There we go. Okay, so something like that. So if it's a default case, it will just be applied, and then there's a sort of like a validation afterwards, just to make sure that
cool.
the valids are
all right. So it's working.
Valid.
Okay, cool. So now that we have it working, then maybe I would like to do a little refactoring because, for instance, it's the exact same thing. So we no, I'm thinking. Okay, so yeah, well, maybe we could do some sort of a normalization of the value. Let's see, let's say normalize X, and this would be normalize Y, and so this method should be exactly, yeah. So it would be something like this, like if X is okay, and let's say else if else it should simply return X, and that will be all. All right, cool. And then we can get rid of this. And somehow it's failing. Why?
Because I think, where we just return X at the end on line 25, well, we're not actually returning anything for the rest of the if statements.
No, yeah, you're right. You're right. I see now what's going on. So it should actually be like this.
Yeah, I think that make more sense. Yeah.
Yeah. Return. Okay. All right. Cool. Now it looks better. Let's see the test running again, just in case. All right. Cool. So all right, I think we got something pretty cool going on. One thing I'd probably still change would be the execute command, which we might want to change a little further, in order not to have because this thing with the if is actually a switch in disguise. But so maybe we could do that. So I'm not really sure how we could do a very big improvement in terms of there will be the need to make the mapping between the character and the command itself. So at this particular moment, I'm not really sure how much we will gain from applying the command pattern. What do you think?
I think we could talk about the command pattern and how it's another pattern which often gets applied to Mars Rover, and and this is an example of why it is a very good fit for this, is because we do have this issue in the execute command method where again we're sort of relying on strings to represent something quite important within this implementation, which isn't a great idea in itself. And again, like you say, a switch in disguise, it is often a sign that the design can be improved upon a little bit here. So if we were to convert these strings into their own respectable classes, then we could just execute the command. And so this would be more about, I suppose in this case with the kata, it would be more about converting these strings to get a collection of command objects, and we just call execute on each of those commands, which would make this solution a bit more polymorphic, and it would tidy up this command, and it would remove the magic strings from this example as well. But that is the command pattern, which is another pattern. So yeah, whether or not we move into it at the moment is, let's see what you think about that.
Okay, so I think we can stop here to not to do too much burden in the heads of the viewers.
Yep. Yep, I agree.
Maybe we can go over what we did again to see So what's left? One thing I want to comment is I guess it's pretty visible, but still I want to remark it, the importance of having good testing test cases in place. Mm-hmm. That was absolutely necessary for us to feel comfortable doing this kind of very heavy refactoring, I would say.
Mm-hmm. Absolutely. Yeah, so really you should try to have a great testing suite for anything you're doing. Ideally, at Codurance, we do try to build things out with a TDD mindset. So we do hold that in high regard as a general principle to follow. And yes, like Mauro says, this is a fantastic example. If you do have a strong test suite, then you can do things like this heavy refactoring, and you can feel safe knowing that your use cases are going to be covered. You can get that immediate feedback from your tools to let you know that you're still achieving the same functionality from when you started. And of course, that combined with another thing which we haven't done in this video, just for the sake of brevity, but of course with changes, we'd be committing a lot and using our version control system to ensure that we're always in a safe place where we can undo our local changes back to a green state. And so those two things combined really give us a really strong foundation within our project, which allows us to make these big changes securely.
Mm-hmm. Yep, exactly. So my final comment would be, even if you didn't or you're not used to working in a TDD fashion, when you're approaching this kind of a refactoring little project, do the test, build the test coverage first, and then you can go about it, very safely. Okay.
Mm-hmm.
So yeah. All right. I hope you enjoyed it. There will be more of this to come. So do subscribe and see you later.
Yep. Thanks very much.